ba 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 director. Man, what am I doing? Hello and welcome to yet another exciting episode of Mr. Bell Physics. As you can see, I'm trying out a bit of a different mic setup today to, add a little bit more range, and also because this mic just didn't really clip that well to this t-shirt, so oh well. Today, though, we are going to be starting our unit on kinematics. This is going to be episode 1 in a series of episodes to kind of go through the entirety of the kinematics unit, both from the very, very beginning introductory conceptual level all the way up to full-on two-dimensional projectile motion with angles and trigonometry. So hopefully you enjoy the series. But today we're going to start off with the very beginning. What is kinematics? Kinematics is best described as the science of motion. It is the science of how things move and how they move over time. Now, movement is what we're going to start with. Okay. Now, the easiest way to kind of start things off is to talk about position. Okay. Every object in the known universe has a set position to it, has a set point that it exists within, right? Now, mind you, this point can change. So I could start by standing over here and then move over here. Crazy how that works. Now, the way that allows itself to happen is through kinematics. The way that my position changes over time can, one, be measured, and two, is all related to various, variables. So to start off with position and how position changes, I have here on the board a number line, okay, going from 0 to 60 centimeters. Now, let's say, for example, we start off at 0. So our point is at 0 centimeters. This is basically like a one-dimensional graph, this number line. And it's an idea that we'll come back to pretty often. Now, let's say I want to change my position. Let's say I went from 0 centimeters to 20 centimeters. My position changed by that much. Okay? I can figure out how much my position changed by doing my final position minus my initial position. We're going to refer to position as x throughout all of this. So x is position. Now, for this video, we'll be using centimeters for the most part, but I am going to convert this into meters because x should always be measured in meters. So, the way that we convert from centimeters to meters is just dividing by 100. So 20 becomes 0.2. And our actual change in position, so delta x, that's what that triangle means, just change in, would be 0.2 minus 0, which equals 0.2 meters. Pretty straightforward so far. So that is how our position has changed. But let's say after that, I decide to move again. Okay. Now, mind you, I'm standing at 20 centimeters right now. But let's say I, with a different marker here, go from 20 centimeters to 10 centimeters. What would my change in position be now? And the answer is that it depends on where you measure from. Now, in physics, there are two main types of way of measuring this. There's distance and there's displacement. Distance is just the total amount of position change, right? So total position change. And this ignores direction. So in this case, if our initial change was 0.2 meters, all we've done now is we've gone 0.1 meters the other direction. So this is 0.2. And then this is 0.1. Our distance would be 0.2 plus 0.1, which is 0.3. So 0.2 plus 0.1 equals 0.3 will be our distance. Obviously, that's in meters. Displacement, on the other hand, does care about direction. Displacement only cares about where we started and where we ended up. So in this case, we started all the way back at 0. And we finished at 10, or 0.1 meters. So according to displacement, our displacement was actually only 0.1. So displacement is the difference between your start and endpoint. In this case, we do final minus initial. So we do 0.1 minus 0.0, and we get 0.1 as our displacement, also in meters. Now, which of these two that you use is rather important in physics because we use these in two different ways. Distance can be useful for calculating an object's speed, but displacement is what we use to calculate velocity, and velocity is what we'll primarily be using. So, for the most part, we'll be using displacement going forward. However, there is a noteworthy difference between distance and displacement. Both have their own uses, but for our purposes, we only really care about displacement. So, that brings us to how we can actually use this in real life. What does this actually look like? So, I'm going to turn on the tripod here and have it start to follow me to this side of the room. Whoa! Crazy how technology works, right? So I should be able to do it. Let's go a little bit over here and stop. Perfect. So what you guys cannot see, since it's off camera, is I actually have a meter stick here on the ground. And all I'm going to do is show you the difference between a distance and displacement kind of thing. So right now I'm standing at 0, and I'm going to do something that I call my distance displacement dance. So, put a little bit of music in the background, if you will. I don't have the editing skills to do that right now, so I'll just do it a cappella, So right now, I want to go both a distance and displacement of 1 meter. So, California girls were unforgettable. Bikinis on top. Sound like that, right? So, all that changed is I moved from my starting position to 1 meter. Okay? So right now, both my distance and displacement is 1 meter. Now I'm going to go halfway back. And we're going to see how these numbers change. So, again, going to do my little distance displacement dance, right? And just go forward, right? We are the champions. No time for losers, because we are the champions. Ba-da! Right? So, I'm here at the half meter mark now. My displacement, how far I've gone from my original position over here, is only half a meter now. But my distance, how far I've gone total, is actually 1.5 meters. So now I'm going to go the rest of the way back, right? I'm going to keep on going all the way back. So, continue my dance. Apple bottom jeans, boots with the fur, with the fur. The whole club was looking at her. Right, we get the idea. So I'm now back at my original starting location. And what that means is that my displacement is now 0. Okay. In terms of displacement, I have not moved. Nothing has changed. But for distance, I went back and forth, meaning that my distance is now 2 meters. Okay. Now, both of those numbers are going to have different applications, right? But figuring out my average velocity, right? My average rate of change of position, I'm going to use displacement for that, which means that on average, I didn't move, right? I started and ended in the same place over a period of time. But let's say gas mileage or something like that. I want to know how much gas I'm going to use, how much energy it took for me to go from one spot to the other. Distance is what's going to be more applicable there. Because, sure, my displacement may have been 0, so according to that, I may not have moved, but I did move. And I exerted energy. I burned calories in order to do that. So that's the big difference. So, yep, that's right hand symbol. So bringing it back over to the whiteboard. So we can see how this idea also applies to our number line here. Okay, it's the exact same idea. Now, understanding the difference between distance and displacement is crucial to being able to start doing actual calculations. So, in the next episode of this, we're going to start talking about what is velocity and what is acceleration. And then, furthermore, we're going to learn how to plot those things on graphs and calculate them. So, as always, thank you so much for watching. Make sure you absolutely can move the mic away from my mouth for this one. Smash that subscribe button and that like button. Make sure you turn on the little bell for notifications so that you know whenever this channel uploads a brand new physics video. And as per usual, I will see you in the next video.